Hello everyone and welcome back to Clinical Cousins YouTube channel, where today we're going to go over the P wave. Now, as we know, the P wave represents the depolarization from the atrial SA node through the atria to the AV node. Now, a normal P wave has a duration of 0.08 to 0.11 seconds. Remember that the P wave should be less than one small square. Now, normally, the P wave has an axis, meaning a direction that points between positive 0 and positive 75 degrees. An important point to note here is that the P wave is negative in AVR and positive in leads 1, 2, V4, and V6. Now, why is this the case? So here we have our heart. And remember, each lead has a positive and negative aspect, but I have just drawn the positive aspects here. Remember the analogy? You are like the positive end of the lead, and the positive atrial depolarization vector is like a pretty girl. So let's pretend that you are AVR, the AVR lead. If the pretty positive vector is moving away from you, how will you feel? You will feel sad, meaning that you will have a negative deflection. This is why the P wave is negative in AVR. Now let's pretend that you are leads 1, 2, V4, and V6. If the pretty positive depolarization vector is heading directly towards you, how will you feel? You will feel happy, and you will have a positive deflection. This is why the P wave is positive in leads 1, 2, V4, and V6. Now, we must note that the P wave represents the first wave in our normal EKG complex. This represents the spontaneous depolarization of the SA node through the anterior, middle, and posterior internodal tracts, through the Bachmann bundle, and eventually through the atriomyocytes and to the AV node. Now, this is important to remember from our previous videos because we also remember that if the heart does not follow this normal electrical pathway for some reason, our P wave may be inverted or it may have a different look about it, known as the morphology. Remember that morphology is simply how something looks. For example, if I told you that a particular heart had a dead SA node and instead it had a pacemaker bundle that was near the AV node. Now, what if I told you that this abnormal pacemaker bundle had an upward and rightward depolarization vector? You would tell me, of course, that the P wave would likely be positive in AVR and it would be negative in leads 1, 2, V4, and V6. This brings us to our next topic, P wave morphology, or simply, how does our P wave look? You only need to know one fact. The P wave morphology, or how it looks, is dependent on the location of the pacemaker. Now, let us say that this is a normal complex in lead 2. What would it look like if the primary pacemaker, or the fastest pacemaker, was located near the left atria? What would that look like? What if the vector was headed downward and rightward? Now, we would say that if the depolarization vector was not headed towards lead 2, it would likely not have a normal looking P wave. Now, if we had a depolarization vector that was headed away from lead 2, we might say that it has a different morphology. It might have a different look about it. Why is this the case? Because the vector is not heading downward and leftward like it usually is. We have a different pacemaker bundle, which is resulting in a different direction of our depolarization vector. Now, remember premature atrial contractions? It represents a bundle of pacemaker cells that momentarily takes control or acts as the captain of the atria. Now, when this abnormal pacemaker takes control of the atria, it may fire its own complex. Do you remember how this looked? All the P waves in a premature atrial contraction have a different morphology. Why is this the case? Because it came from a different part of the atria. Now, what if this captain or bundle of irritable pacemaker cells started to depolarize very quickly? Yes, it would be ectopic atrial tachycardia. And what if we had 3 or more different looking P waves? Yes, this would be wandering atrial pacemaker. And what if these 3 or more different pacemaker cells started firing rapidly, leading to tachycardia? Yes, this is multifocal atrial tachycardia, known as MAT. So, what have we learned today? We have learned that the P usually is negative in AVR because the positive depolarization vector moves away from AVR. We have also learned that this positive depolarization vector usually heads towards leads 1, 2, V4, and V6. Therefore, the P wave in these leads will likely be positive. Lastly, we have learned that the morphology of the P wave, or how the P wave looks, simply depends on the location from where the pacemaker cell is firing from and how fast that pacemaker bundle is. As always, thank you for taking the time to learn with us today, and remember to like and subscribe for more content.